Hello, assalamu alaikum everyone. My name is Aisha Khalid and welcome to my channel Math Madness by Aisha Khalid. Alright, so in today's video we will discuss kinematics and we will do a quick overview of the concepts, and then we will do a couple of past paper questions to have a better grip of the topic. If you want to thoroughly understand the topic, then you need to watch the other parts of it. In this video we will just quickly overview the concepts. Alright, we have displacement, we have velocity, and we have acceleration, and these are all vector quantities. That means they are all with a direction. When you differentiate displacement, you get velocity. When you differentiate velocity, you get acceleration, and the vice versa process is called integration. And every time you integrate, you add a plus c to it. Remember, displacement and distance are two different things. Velocity and speed are also two different things. Alright, when they say initial velocity, some of the keywords means initial velocity means time, initial velocity, displacement, acceleration means time is equals to 0. Maximum velocity or minimum velocity means that the differential of velocity is 0, and the differential of the kinematics is with respect to time. Minimum maximum acceleration means differential of acceleration is equals to 0. Minimum maximum displacement means displacement differential is equals to 0. Some of the key pointers that you need to know. So let's start with the past paper questions to have a better grip of the topic. Okay, a particle P is moving in a straight line such that its displacement from a fixed point O is given by the term S is equals to 12e minus 0.5t plus 4t minus 12. Now find the value of t when P is instantaneously at rest. Rest means velocity is 0. So first thing is, this is a displacement equation, so differentiate it. How do we differentiate the exponential function? We copy it, multiply by the differential of the power. So this becomes a minus 6. Now when velocity is 0, when E shifts on the other side, it becomes an ln. And T is equals to, so this becomes ln 2 upon 3 divided by minus 0.5. My value of T comes out to be 0.81 seconds. Alright, find an expression for acceleration. Acceleration means you have to differentiate the velocity expression further to get the acceleration expression. Now how do we get the exponential differential? We copy the same thing, multiply by the differential of the power. The constant has a differential of 0. So the acceleration becomes plus 3e minus 0.5t. This is my answer. You need to have very strong differentiation integration concepts to get the hang of kinematics, because O-level kinematics comprises of log, trig, exponential, algebraic, all sorts of functions. Find the value of displacement when the acceleration is a 0.3. So let's put the acceleration as 0.3, 3e minus 0.5t. So and find out the value of t from here. 0.3 divided by 3 gives you a 0.1. ln 0.1 equals to a minus 0.5t. Divided by minus 0.5 gives you the time value as a 4.6. Now, value of displacement. So we have the displacement equation, which is S is equals to 12e minus 0.5t plus 4t minus 12. So in place of t, I will just input a 4.6. 12e to the power This gives me the displacement value of 7.6 meters. That means at time 4.6 seconds, the particle is 7.6 meters away from the fixed point O. Because they asked for the displacement, not the distance. Acceleration of the particle will always be positive. Okay, so I'll answer this part here. If you talk about the acceleration, it is an exponential function. And for exponential function, we need to know how does the graph look like. So remember that this is my asymptote. And when I put the time value 0, 3e minus 0.5 into 0, this becomes a 3. That means this is the value of 3. And a negative exponential, the graph looks like this. So therefore, you can see for t greater than 0, that means for a positive value of t, you can see the acceleration is always positive. It doesn't go in the negative region. The acceleration is positive. So the acceleration will always be positive. It is also shown by the graph that I've drawn, because this is how the exponential graph looks like. Alright, so let's start with the second question. Now this is a linear graph. In the previous question, it was an exponential function. That means it was a non-linear kinematics motion. Now over here, it's a linear motion because I can see straight lines on the speed time graph. I find the acceleration during the last 6 seconds of its motion. Last 6 seconds means I have to find the gradient of the last 6 seconds, which is, I will take this point k in k comma 10. The last point is a k plus 6 comma 0. Because you know that in a speed time graph, the gradient represents the acceleration. 0 minus 10, k plus 6 minus k. So this becomes a minus 10 upon 6, which is a minus 5 upon 3. So this is my acceleration for the first part. Second part. The particle travels with constant velocity for 23 seconds. Find the value of k. So for 23 seconds, it travels with a constant velocity. So 4 plus 23 means at 27 seconds. That means that is my value of k. Part 3. Using your answer to part 2, find the total distance traveled by the particle. So the distance traveled is the area under the graph. So I can see this entire figure is a trapezium. So I will apply the trapezium formula, which is half into height into sum of parallel sides. This is the area of trapezium. Half into the height is 10 into one side is a k plus 6 plus the other side is a k minus 4. And they're asking us to find the answer of, use the answer of part 2, which says the value of k is at 27. Plus 6 plus 27 minus 4 is a 56. 2 times 1, 2 times 5 into 5 gives you a 280. Alright, so this is my answer for the third part. Now let's move on to another linear motion questions. Find the deceleration of p for the time value between 5 to 10. 5 to 10 means this is 5 and this is 10. So I have to find out the deceleration, meaning this point is a 5 comma 20 and this point is a 10 comma minus 20. So we have to find out its gradient. 20 minus 20 divided by 5 minus 10. 40 divided by minus 5, my velocity is a minus 8 meter per second. Write down the value of t when the speed of p is 0. When the speed of p is 0, that means at this point I want to know what is my value of t. So I can say all 3 points lie on the same straight line. So the gradient is the same. So I will use the gradient concept. Minus 8 is equals to, gradient is, deceleration. So the gradient is a minus 8. Point is a t comma 0. Another point I'm taking is a 5 comma 20. I can take this point as well, doesn't matter. 20 minus 0, 5 minus t equals to a minus 8. 20 equals to a minus 8, 5 minus t. 20 divided by minus 8 gives you a minus 2.5, minus 5. That means the time value becomes a 7.5 seconds at which the velocity is 0 or the speed is 0. Find the distance of p has travelled for 0 to 10. So 0 to 10 means this is the distance that it has travelled and this is the distance that it has travelled. So find out for the first part, it's a trapezium and this value is a 7.5. Half into the height is 20 into the sum of sides is 7.5 plus this is 5 plus half into, this is a triangle, so this is 20 into 10 minus 7.5 is a 2.5. Now let's do the addition. This is a 125 plus 75 gives you 200 meters. Now this is the distance that it has travelled. A particle q has a displacement from the fixed point, the velocity of the t. Find an expression for x in terms of t. Now x is the displacement, meaning we have to integrate it. How do we integrate? So x is a displacement, so I'll write x here. Copy down the function divided by the differential of the power plus t plus c. It starts from a fixed point O, t seconds after leaving O. That means when time is 0, my displacement is 0 because it starts from that particular point. This particular thing will help us to find the value of c. X is 0. 0 is equals to 3. X equals to, so this becomes my displacement expression. Remember, whenever we integrate, there is always a plus c in it. Stay tuned for the next video and like and subscribe and notify my channel, because in kinematics we need to do a couple of more questions to have a good grip on the topic. Allah Hafiz.